Hi everyone, we are the group Drink More Water. Today we'd like to talk about our team project for the data mining. The team consists of me, Sherwynd Liew as team leader, TEOH Ming, Hong Kairen, CELINE Ying, and Lee. Let's move on for the introduction of our project part. I'll pass it to Karen.
Next is problem statement. So in Malaysia, many people think that boil the water or just filter the water is become potable. But actually, the water is actually contain many harmful contaminants even after you boil or filter the water. So our group project is to seek to examine the factor affecting the water quality and to determine the current water treatment methods is effective in ensuring the safe drinking water or not. Next, our group project having three objectives. First is to assess the impact of water quality parameter on the probability. The next out is to identify the key contaminants for the water probability. And then the last one, we will build a predictive model for water quality prediction. Next out is our dataset selection. So our dataset title is water quality. So the dataset is from Kaggle. It's a public accessible dataset. So next out, after we select the dataset, our sampling method used is random sampling. This is to minimize the bias of the data.
Now I will present about the explore step. So first we conduct automated data explorations by using pandas profile rings. We find out pH, sulfates, and triharometers contain the missing values. They need to be identified the types and then determine how to handle them in the modify step. Second, we also conduct auto viz and we find out that all features actually contain the outliers. And from these visualizations, we also can easily identify the ranks for each feature. For example, the ranks of pH is between 0 until 17. Beside automated, we also conduct manual data explore. First is we use the histograms and we find out that most feature is nearly symmetrical distributions, but only solid is slightly negative scale, and this means that most water sample have relatively high concentration of solid. The second one is box plot. So for pH, hardness, and solids, actually that contain the outliers, and we decided to retain the outlier because we want to use all of this record for predicting and supporting the conclusion that water falling within this rank is unsafe to drink. The third one is pie chart, and this indicates a slight crust imbalance that is unlikely to affect the performance of the training process. So we decided to retain it and haven't implement any crust imbalance handling methods. Next, we also conduct correlation metrics because we want to identify the impact of water quality parameters on the potabilities. And since the relationship between water quality parameters and potability is not linear, so it suggests that each of the variables are independent in terms of their linear associations with potability. Besides that, we also conduct scatter probes to identify the impact of pH, hardness, sulfates, and chromics on the potabilities. The result is the cluster data points, and this suggests the non-linear relationship and therefore indicate that these variables are independent of each other in terms of the linear dependencies. So next, I will pass to Celine to present about the modified step.
So now we're going to perform the modify stage. We found out that the pH, sulfate, and trihalomethane column contain the missing value. We have plotted the heat map and the yellow line show that there is a missing value, so we predict that it is likely the MCER type. And this is a data distribution for the column with missing value before perform the imputation technique. In order to identify the missing value type, we have performed the little MCR test, variety test, and also logistic regression test. So if the p-value is larger than 0.005, that means the missing data type is MCAR. So for the little MCR test, the results show that the missing data is MCAR. So to further enhance the result, we have performed variety test, and the results show that most of it is MCAR type. Only one column show that it is likely MAR or MNAR. So we can conclude that it is MCAR type. So for the logistic regression test, we have calculated the area under the curve score for each of the column, and the result is close to 0.5. So we also conclude that the missing value type is MCAR. Now we want to perform the imputation technique. We have tried 7 different methods, and we use the Shapiro wheel test to test whether after perform the imputation technique, the data is still normally distributed. The null hypothesis is that the data is normally distributed. So if the p-value is smaller than 0.05, then we will reject the null hypothesis. So for drop missing value technique, you can see that trihalomethane column, it is failed to reject the null hypothesis. That means after perform the imputation technique, the data is still normal distributed. So for the other columns, is reject the null hypothesis. So for mean imputation technique, median imputation technique, mode imputation technique, random imputation technique, multiple imputation technique, and also the can-end imputation technique. All of it show that it reject the null hypothesis. So we can conclude that the best choice of our imputation technique is simply dropping the missing value. After dropping the null value, and then this will be our sample data size. Lastly, we perform the feature engineering. We rename the column organic carbon from the snake case to Pascal case to enhance the consistency also and the readability.
So I am Zhongming and I will be presenting the results of our classification model evaluation and also the selection process for this project. So we evaluated machine learning models, 7 machine learning models. The first is logistic regression, the second decision tree, random forest, XGBoost, SPM, neural network, and also KNN. So each model was assessed using metrics such as accuracy, precision, F1 score, and also recall, and the last one, confusion matrix. So for the logistic regression, the accuracy is 0.57, precision 0.5, recall 0.01, and F1 score 0.03. So the essentially better than logistic regression in the precision, recall, and also F1 score, although the accuracy is slightly reduced a bit. So random forests outperform both logistic regression and decision tree with an accuracy of 0.63 and precision of 0.6. However, its recall was moderate at 0.39, resulting in an F1 score of 0.47, which reflects a reasonable balance between the precision and also the recall. So for XGBoost achieved an accuracy of 0.61, precision 0.56, recall 0.45, and F1 score 0.5. For the support vector machine SVM model, it achieved the same accuracy as the random forest at 0.63 with a precision of 0.63, showing reliable positive prediction. However, its recall was lower at 0.32, leading to a lower F1 score of 0.42, indicating an imbalance between precision and also the recall. For the neural network MLP model, it emerged as the top performer among all the models. So it has the highest accuracy, which is 0.66, precision 0.63, recall 0.49, and also the F1 score 0.55. So demonstrate its ability to maintain a strong balance between identifying the true positive and also the making accurate prediction. So finally, for the KNN, K nearest neighbors, it closely follows the neural network in performance with an accuracy of 0.65, precision 0.63, and recall of 0.45, and its F1 score is 0.52, indicates a balanced performance, making it a strong contender for the classification task. So after all the modeling, we can come up with the assessment, which if we look at the accuracy score, we can find out that the neural network have the highest accuracy between all of the models, which have the 0.66 accuracy. The second one is k nearest neighbors. So we at the end we choose the neural network as our model to do the prediction. So besides using the accuracy score, we also use analyze the conversion matrices, which provide variable insights into the true positive, true negative, and also the misclassification rates. The neural network consistently minimizes the errors across both positive and negative classes, confirming its suitability for our classification tasks. So finally, we can see from the accuracy score and also confusion matrix, the neural networks model demonstrate the best overall performance, making it the most suitable choice for this task. So the trained neural network was set using the job lake library, so ensuring the efficient serialization and also reusability. And we integrate the downloaded file into our prediction website to do the prediction on the water potability.
I'm Sherwynd, Liew, the leader of this team, and will talk about for the prediction of the project architecture and also for the demo and the conclusions. As you can see, I'm using a front end for the Next.js and a back end for the Flask. The Flask is using from the Pythons, and all of the model will be fetched using a job library. So the job library will then predict the data and send to the API of the Flask, and then the Flask will send the response to Next.js. Next.js will compile to a human image or a language form, then we'll send the display to the user. User will also can able to send the data for them, and then they will predict it. Moving on for the demo parts, we have the enter quality data forms to predict the water potability. They include of pH, hardness, solids, chloramides, sulfates, conductivity, organic carbons, trihalomethanes, and last but not least, turbidity. All of them are filled in number value, and all of them must be in positive. And also, if one of the form is not filled, such example one of it, so we'll have a validation to checks and we'll send a required data. So once all of it have filled in, so it will then have a button to have a submit. So we submit the buttons, it will showcase it the result of whether your water is drinkable or your water is not drinkable and is highly dangerous, which showcase the potability of the waters. In conclusion, our analysis have revealed key insights into water potability and the factors influencing it. First, we found that all analyzed water quality parameters such as pH, turbidity, hardness, and chloramides, and so on, played a role in determining whether water is potable, highlighting the complexity of water quality assessments. Additionally, we identified the specific contaminant such as chloramides, a sulfate level with high and low, as strong link to non-potable water, which emphasizing their critical importance in assessing water safety. Last, our machine learning neural network achieved the highest accuracy of 66%, provide preliminary tool for predicting water potability, while the models offer valuable real-time decision-making capabilities. Further refinement of the dataset is important or as essential to improve the accuracy and reliability in practical applications. This finding underscore the importance of comprehensive water quality monitoring and the potential of machine learning in addressing public health challenges. Thank you.